Okay, this is part 2 for section 2.6. Okay, there's only a couple examples here, but there's a lot to do in each one, so let's try to get through this. Find the intercepts, analyze, and draw the graph of the rational function. Now guys, when it says analyze, like that, you need that. Okay? So you have to make sure that when it says analyze, you're finding all 9 of these things right here. Okay? So we'll go back. Now, there's no particular order you have to do this in, but I would probably say first, okay, I would do domain and range, I guess. So, domain, whoops. So domain set x squared minus 4 equal to 0. So x squared, so, well, here, we don't need to work this out step by step. You guys know how to do this. So x is plus or minus 2. Now, what that means is that x can't be plus or minus 2. So I go to my I don't even know what you call that. It's my things, my analysis. There you go. There's a word, analysis. And I'm going to keep doing that, probably. Don't forget, domain, you're really going to start out with all real numbers, all x's, okay, all x's. Since negative 2 and 2 are the only numbers that don't work, you have to account for when it's negative infinity to negative 2, negative 2 to 2 because the numbers in between negative 2 and 2 work, so you got to include those, and then 2 to infinity. Now the range. Now the only issue with the range here is when you graph this, okay, first of all, you're going to have vertical asymptotes at 2 and negative 2, and you're going to have a horizontal asymptote at 2. Hopefully you know why the horizontal asymptote's 2. Degrees are the same, so 2 divided by 1 is 2. Okay, so the graph is really going to look like this. And you can do, I figured this out by graphing it on the calculator, okay? Okay. Now, the range are all the y's. So I just start working my way up. So all the y's are good. 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 And then all of a sudden it turns and heads back down. Okay? So there's some sort of, whoops. Okay, so the range goes from negative infinity. Now we got to figure out what that number is. Okay? Now, unfortunately, the only way you're going to figure that out is by using the graph. Okay? All right? Now, well, actually, you don't even need to use the graph. This point right here is the y-intercept, right? So, how do you find the y-intercept? Okay, we talked about this before. Let x equal 0. So, if I let x be 0, both of those go away. What's left? Negative 2 over 4, or over negative 4. Which is a half. So the range is good all the way up to the y-intercept in this case. So 1/2. Now, union. So we skip everything from negative 1/2 up to 2. Now again, we're on the y-axis. We're looking at that. Okay? So all the y's up to 1/2 are good. Okay? Now, what just happened? What happened? Something happened. My graph disappeared. Oh well. So, we'll just write it down here. What a disaster this lesson has become. Okay. So anyway, erase some of this extra. Alright, anyway, so from negative infinity to 1/2, we're good. They skip, there's no y values from 1/2 to 2. None. Okay? But, as you can see with the branches of the graph, okay, there are values from 2 on up. So, 2 to infinity. Notice parentheses on 2 because we have a horizontal asymptote at 2. Is it continuous? It is not continuous. Okay? Increasing, decreasing. Oh my dear Lord, there's so many things to look at here. Okay? Increasing. So again, increasing is we're looking horizontally. We're starting at negative infinity and we're going to start to look this way. So this branch right here is going and it looks like it's increasing because it's going to increase all the way to infinity. Okay, well what interval is that? Well, that's from negative infinity to negative 2. So, increasing. Negative infinity to negative 2. Is it increasing anywhere else? Well, it's increasing in the parabola. It's increasing all the way up to the y-intercept. Okay? So it's increasing from negative 2 to 0. Because here we are on the parabola. Here's the vertical asymptote of negative 2. It's increasing, 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 and it gets to x equals 0, and then it starts to decrease on the other side. Okay? So our decreasing, okay, would be from 0 to 2, and then from 2 to infinity. Because it's decreasing here, and it's decreasing here. It's getting smaller. Okay? What else do we have to find here? Symmetry. Symmetry. Okay? If you think about it, this graph is really symmetric about the y-axis. Now, how do you figure that out? Well, plug in f of negative x. Well, what happens? 2 times negative x squared minus 2 over negative x squared minus 4. Well, negative x squared is x squared. So f of x is going to wind up equaling f of negative x, which means this is an even function. Okay? It's not bounded. Okay? It's not bounded. Now, extrema. Now, we have a parabola here. Okay? It's an upside-down parabola. What that means is that we have a local maximum. The branches out here don't count. Okay? If you have a parabola, okay, you have a local max or min. In this case, it's a max. So we have a local, we have to be very specific about that. It's a local maximum, not an absolute maximum. It's a local max at 0, 1/2. Okay? Now, asymptotes we already did. Vertical asymptotes, x equals 2, x equals negative 2. Remember to write them as equations of lines. Horizontal asymptote, y equals 2. End behavior. Now, when it says end behavior, we are not doing the limits that we did from the first part. We are only going to do, if it says end behavior, we are only going to do as x approaches infinity and negative infinity. Okay? So, as x approaches negative infinity, what's happening to our graph? It's going down, 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 and it's approaching the horizontal asymptote, which is 2. And the same thing happens on the other side. Okay? Now, it said, I believe it said find the intercepts. Okay? Find the intercepts. Well, when it says to find we found the y-intercept. The y-intercept was 0, 1/2. Okay? The y, or the x-intercept, okay, we want to let y equal 0, or let f of x equal 0. Same thing. Okay? So, what happens? we set the numerator equal to 0. So 2x squared minus 2 equals 0. So add 2. No, it's supposed to add 2. It's not 0. There we go. Divide by 2. Take the square root of both sides. X is plus or minus 1. So my x-intercepts are 1, 0, negative 1, 0. Right here. Okay. So after 10 minutes and me losing the problem, we're done. Okay. Now, example 7 is a little bit shorter. It says, find the end behavior asymptote. Okay? End behavior asymptote. Now, this is very easy. The first thing you want to do is find the vertical asymptote. Vertical asymptote is x equals 1. Okay, if you don't know how to find a vertical asymptote, see me. Now, to find the end behavior, excuse me, to find the end behavior asymptote, you're going to take that 1 and you're going to put it in the box, and you are going to do synthetic division on the top. Drop the 1, negative 2 times 1. Okay. Now when you do synthetic division, what happens? Your resulting polynomial will be 1 degree less than that. So I've got x squared minus 2x plus 1 plus the remainder, which is 2 over x minus 1. Now, where does the end behavior asymptote come into play? This is the end behavior asymptote. Okay? So not the remainder. The remainder is no part of that. But the polynomial you get from the synthetic division is the end behavior asymptote. Okay? And if you want to see how that works, you can graph this on your calculator. Okay? You can see how this asymptote works. Okay. Now, for example 8. Now we got to get rid of all this. Try to make this as simple as I can, guys. I know it takes a lot of time, but there's a lot of things we have to find. Okay? Just bear with me. This video hopefully will be shorter than part 1. The other thing, guys, is hopefully you know how to do most of this already. All right? There's not a whole lot new here. Okay? But I know we struggle a lot with the analysis. So let's see what we can do here. Find the intercepts. Analyze. Draw the graph of the rational function. Okay. Well, let's do this. X-intercept first. Okay. X-intercept first. Now, that's a cubic. You're letting this equal 0. So what I would do is I would graph this. I would graph the numerator. And I would find the x-intercepts. Okay? Now, in this case, there's only one x-intercept, and it is negative 0.26. And again, you can easily verify that by graphing it in your graphing calculator. Okay? Now, guys, if the numerator is a quadratic or a linear, solve it algebraically. But if you're third degree or higher, just graph it and figure it out. Y-intercept. Y-intercept. Okay, so we let x be 0. So 0, 0, 0, 0. What's left? Positive 1 over negative 1, which is negative 1. Okay, so intercepts. Check. Analyze. Domain. Domain. What can't x be? Well, there's the denominator. So x can't be 1. So my domain, negative infinity to 1, union 1 to infinity. That thing just keeps coming. Okay? Now, range. Range. Here's the idea. Okay? The range, if you look at the graph, if you graph this whole thing now in your calculator, all right, you're going to see there is no restriction on the range. The range is all real numbers. Now, you're going to get that from the graph, so make sure you understand that. Okay. Now, continuity, by the way, this is the graph. So you have a vertical asymptote here. Now, if you'll notice, this was the same problem as this one. So we have the end behavior asymptote. Hang on, asymptotes. So the vertical asymptote was x equals 1. The end behavior asymptote is y equals x squared minus 2x plus 1. Now, when I go to graph that, okay, at 0, I get 1. The vertex is 0, or 1, 0, excuse me. Here's, so symmetry can put you on the other side. So your asymptote is actually a parabola. Okay? Now, we found our x-intercept was at negative 0.26, so it's right about, whoops. Our x-intercept is right about, come on, right about there. This is really annoying, kids. Okay? So as you see, and your y-intercept is 0, negative 1. Okay? So your graph kind of hugs along there, and then it kind of goes down like that. That's the first piece. The other piece really kind of goes in here. Okay? Alright, so that's what you're going to see in your calculator. Now, continuity. This part is continuous. This part is continuous. Where's the break? Well, the break is at x equals 1. There's the jump, right? Actually, it's an infinite discontinuity because there's an asymptote. So our continuity, it's continuous on all x except for 1. Now, oops, wrong way. We want to find increasing, decreasing. Well, to find increasing, decreasing. Well, decreasing, this whole thing here decreases. So from negative infinity to 1, it decreases. Now, for the parabola, so for this parabola, we got to find the vertex. Okay? Well, what's the vertex of that? What's the vertex of this right here? Well, your local max, okay, or your local min, excuse me, your local minimum, okay, and when you find minimum, use your calculator to find this. So the coordinates of that point, that's the local minimum. Use your calculator, the minimum function. So what's going to happen is that is actually at 2. It occurs at x equals 2. Okay? So from 1 to 2, oops, bracket, it's decreasing because we're going down to 2. But now from 2 to infinity, it's increasing. So it's increasing from 2 to infinity. Symmetry, there is no symmetry. None. Bounded, okay, is it bounded? Not really. Extrema, we have a local min. Okay, we have a local min at x equals 2. Well, if I plug 2 in, I get 3. Okay. We did the asymptotes, end behavior. End behavior. So again, limit. X approaches, God bless it. Limit of f of x as x approaches infinity. Okay? As x approaches infinity. So we're looking out there. Here's our graph. What is it approaching? Okay? It's approaching infinity. The graph is getting larger and larger and larger. So infinity. Now, limit f of x as x approaches negative infinity. So I go back. Now I'm looking out this way. Well, here's my graph. What's happening to the graph as x gets smaller? It's getting bigger. Unlimitedly bigger. So, infinity. Okay? So, again, you have to understand how to do the analysis. Sometimes your graphing calculator will help you with this. Sometimes you have to kind of do it by hand. All right? The more practice you get, the better you'll be at it. Okay? So be prepared. You only have 8 problems tomorrow or for this section, for this part. So hopefully we can get all those done in class.